Welcome to UGC lecture series on computer science. We are going to discuss about the topic on cloud computing. In this episode, we are going to discuss about the differences between data, information, knowledge and wisdom. What is data? Data is the raw data which is consisting of set of symbols or set of facts or set of truths, that is known as data. It does not convey anything. When you consider the information, how do you relate to data? Once if you understand the actual relations between two data, the data will become information. For example, 50, it is the raw data which represents a number 50. Suppose if I say mark 50, when you correlate mark and 50, it will become information. That is why once if you understand the relation between the data, it will become information. Then what is knowledge? When you understand the pattern in that information, then it becomes knowledge. Say for example, today the temperature is 5 degree. Today the temperature is 30 degrees. What do you infer out of these two information? Temperature 5 degrees, it represents winter season. Temperature 30 degrees, it represents summer season. Based on the pattern of the temperature, you say it is winter or summer. So, once if you identify the pattern of the information, you are able to infer the knowledge, that is known as knowledge. Then what is wisdom? If you understand the principles behind that knowledge, then it will become wisdom. For example, during the summer it is very hot. Why? The sun is closer to earth. During winter it is very cold because the sun is far off. This is the scientific reason for the temperature differences. Like that, wisdom is giving the principle. You can compare the spiritual literature. They are giving so many philosophies. Once if you practice, you can understand all those philosophy. So, the wisdom can be reached once if you understand the scientific reason behind the particular truth or the philosophical reason for so many facts, that is known as wisdom. So, from data to information, you should understand the relationship. From information to wisdom, knowledge, you should understand the pattern. From knowledge to wisdom, you have to understand the principle or philosophy. So, this is the understanding versus connectedness. So, data, it gives no information, you know nothing from the data. Information gives what part of it, knowledge gives how part of it, wisdom gives why part of it. This is also another interesting slide representing the understanding versus the context. The data, just gathering of parts, you are gathering 5 and 0, that becomes 50. Gathering of parts is data. Information, connection of parts, when you find out the relationship, that becomes connection of parts, then it is information. Then knowledge, formation of a whole, what is the conceptual idea you are inferring, that formation is known as knowledge. Then wisdom, joining of wholes, you are having different conceptual idea, you are joining everything so that this is the philosophy, this is the foundation, this is the actual principle, that is known as joining of wholes. So, whenever you experience based on the past, you will be simply having data when you are infant, then you will gain information based on your previous experience, past experience, you will gain knowledge, and once if you further improve your knowledge, you will be gaining wisdom. So, we are traversing from data to wisdom. Once if you reach wisdom, then only you are reaching the end of the knowledge. So, it is essential to understand the differences between data, information, knowledge and wisdom. Using computers, so far we have inferred some sort of knowledge also. We are having so much of information obtained out of the data, and knowledge is also being inferred by means of data mining. You are having data warehouses, you are trying to infer the knowledge by applying certain rules, by applying certain logic. So, up to knowledge we are working, still that knowledge extraction is not yet matured. Beyond knowledge we have to reach wisdom also. So, once everything is obtained, then only you are able to succeed. When you consider the operations on data, whenever you make use of the computers, the data is available in binary format. It can operate only the binary data. What are the operations you can perform? Already we have discussed about data, information, knowledge, wisdom. But what operations you can perform on data? First of all, you can acquire the data, you can represent the data by means of different machine code, ASCII representation. You can have the different JPEG format, MPEG format, audio video format, everything is data representation. Then data storage and retrieval, whatever type of data you are having, you are going to store it in the computer memory, you are going to retrieve it, then you are going to transfer the data from one place to another place. You are compressing the data whenever the data is enormous to be transmitted. You are doing the coding to hide the actual information, you are encrypting it or decrypting it, so that you are having the coding, so that you are hiding the information. You are converting one data format into another format, so that you are able to read it in that computer. See, the data available in the Word may not be read in Unix system. So, they are having the conversion mechanism. Once the OpenOffice is having the compatibility to read Office, then you are converting that format into this format. So, like that the data conversion from one form to another form is another type of operation. Then data visualization, by having the data, sometimes we are drawing the bar chart, pie chart, some graphs, so that you will be able to understand the statistical value of the data. What is the highest value, highest mark in that class? By having the mark chart, you will be knowing the highest mark. What is the average mark? How many students are above average? So, like that we are able to find out lot of things out of this data visualization. Then data mining. See, data mining means you are trying to mine the data. Whenever you mine the gold mine, the gold ores are taken out, then you segregate the gold out of that gold ore. You are having some processing. Since you are having the coal in the coal mines, the coal ore is taken out, you are just mine the coal from the core, and that other parts are simply segregated. So, data mining is also similar to that. You are having so much of chunks of data, and all the data are not useful. Unwanted data are filtered out, and only the essential data is extracted. So, we are inferring knowledge out of data mining. Why I have shown all those operations? You can have some more operations also, data copying, data merging, data sorting, so many things, searching, many things are available. I have given some of the basic operations. Here some operations represent only data, some operations represent the information, some operations will be helpful for inferring knowledge. For that, here you are having data mining, that is knowledge extraction, visualization, conversion, coding, these are all information, data to information, and all other things are using the raw data. So, you can imagine the different operations that can be performed over the digital data, so that it will be helpful for different applications as well as for the societal applications. So, you should understand the operations on data. Now, let us discuss about Internet of Things, IoT. It is the buzzword used in the industries nowadays. Since internet is very much popular, we are talking about Internet of Things. Internet of Things is already here. This is the prediction. The source is Cisco IBSC 2011. The actual picture is depicting the connected devices per person. In the year 2020, you will be having 6.58 devices connected to individual person. The total population will be 7.6 billion, connected devices will be 50 billion. Is it possible? Yes, it is possible. See, according to the prediction in 2015, per person you will be having 3.47 devices connected to an individual. Now, it is 2013. How many devices are connected to you? You are having your wristwatch, in which some of the connectivities are possible. You are having the mobile phone, which is connected to internet. You are having the camera, which is connected to internet. You are having the audio video files played. You are having the laptop. You are having the iPad or Kindle or so many electronic gadgets, tablet. Right now, you are having more than 4 connected devices, in the year 2013 itself, whereas they have predicted that by 2015, connected devices per person will be 4. So, from this you can understand, by 2020 you will be having more than 7 devices connected to individual person. So, Internet of Things is already here. Once if you are connected, the data can be converted into information, information can be converted into knowledge, then let us think of converting into wisdom also. What is Internet of Things? There are lot of definitions. Just you can go through the definition. According to Wikipedia, the Internet of Things, also called the Internet of Objects, refers to a wireless network between objects. Usually the network will be wireless and self-configuring, such as household appliances. According to WSIS 2005, by embedding short range mobile transceivers into a wide array of additional gadgets and everyday items, enabling new forms of communication between people and things and between things themselves. By communicating across persons, by communicating across the different objects, you are able to do some fruitful action. The term Internet of Things has come to describe a number of technologies and research disciplines that enable the internet to reach out to the real world of physical object. The internet is reaching the table, not only to the computer, to your table, to your book, to your bag, to your dress, to each and every entity we are using every day, to your food. You want to eat hot food, automatically once that vessel is connected to the internet, the temperature is sensed. If it is cold, then automatically it will be heated. So, like that you are having lot of mechanisms to be evolved once the different items are connected together. Now, when you are in the office, you want to start by using the cloud computing. Before you reach, you want to have your coffee ready, you can just have a click by using your mouse. The instruction will be passed on to the device which is available there. Coffee maker will be automatically preparing the coffee. Once if you reach home, you can have a sweet coffee. Let us have a break. So, this is the reason for connecting different objects through internet. Once you consider the internet history, Internet of Things, here in 1997 we had the challenges to the network, how to connect various objects. In 1999, Auto ID Center, founded in MIT. Auto ID means automatic detection of the various parts in the assembly line. Whenever a part is missing, automatically you can identify that that part is missing. So, for that only they used the Auto ID Center, and in 2008 we had the first international conference of Internet of Things, IoT 2008 in Zurich. And what is the Internet of Things? From any time, any place, connectivity for anyone. We will have the connectivity for anything. So, the actual dimension, if you see, anytime connection, any place connection, anything connection. This is what the Internet of Things. Here the concept was evolved through RFID tags. First the vertical applications evolved, then the ubiquitous positioning of all those things took place, and the RFID tag was used, and from the RFID tag it was extended to two-way communication, resulting in the latest NFC technology. Everybody is familiar with Bluetooth technology. Bluetooth is meant for wireless transfer. Most of you would have experienced in copying your audio video file from one mobile to another mobile, or from laptop to your mobile. So, you are doing the pairing operation, you pair the device. If you enable the Bluetooth on all the devices, automatically it will be having the pairing of the devices. Once if it is paired, you can copy it. But NFC is another recent concept evolved, it is two way. See, it is having lot of applications. Once the device is NFC enabled, you can make use of this NFC technology for certain applications. Bluetooth versus NFC, what are the differences? Bluetooth and NFC are wireless mobile communication technologies for short distances. NFC does not require the pairing concept as required in Bluetooth. NFC is more secure than Bluetooth. The maximum distance covered in Bluetooth is 100 meters. NFC is covering only 20 centimeter. NFC is much slower than Bluetooth. It is possible to have the NFC enabled cell phone in the toll booth and all. Once you are having the reader, then you can show the NFC enabled cell phone, it will detect the amount for that fee, and then the gate is open and you can cross. So, it is made automatic. Up to 10 to 20 centimeters you can keep the cell phone closer to that reader, then you are able to do the remaining task. So, this is one of the applications. Like that, once if you have the NFC, there are lot and lot of applications for so many purposes. Now, in the Internet of Things, we have started with RFID, and it is used for locating the distant objects, the presence of the particular person in a particular location, all those things are happening. Now, telepresence and teleoperations are the recent trends using Internet of Things. Here, when you consider the characteristics, you are having the flexible structure. By having the Internet of Things, you are having the flexibility. Semantic sharing is possible. In the meaningful way, we can share the things based on the various things you have reached. Then complex access technologies are possible, that is, it is possible to access so many complex items. It is event driven. Whenever some event occurs, then you can initiate some other operation. Then it is possible to have ambient intelligence also. Based on the condition, intelligent decisions can also be made. These are the various characteristics. Why should we go for Internet of Things? First, you can have the dynamic control of industry and daily life. You can improve the resource utilization ratio, better relationship between human and the nature, forming an intellectual entity by integrating human society and physical systems. So, these are the main advantages. This is one of the applications of IoT. We have considered scenario of shopping. See, the first one is when entering the doors, scanners will identify the tags on the user's clothing. When shopping in the market, the goods will introduce themselves. You can have the audio video files played so that you can know what are the features of that particular product, what is the cost of the product, what are the specifications, everything will be self explanatory. You need not ask anyone to explain all those things. When moving the goods, you are trying to purchase that good. When you move the goods, the reader will tell the staff to put a new one. Okay, already that item has been sold, you replace it by some other one. Once if you pay for the goods, the microchip of the credit card will communicate with the checkout reader. When you leave out, automatically it will be allowing you to open the gate and you can just come out. So, it is one scenario explaining the importance of IoT. There are lot of applications, say smart city, it is one of the applications where Internet of Things will be possible. Smart traffic, it is possible to have all those things in the smart city. Like that, you can have the different applications where internet is useful for communicating with various devices and you are getting the things done. The state of art of IoT is having RFID, sensors, smart technologies and nanotechnologies. All those things are helping to enable IoT. So, the main concept is anything, anytime, anywhere. Everything in daily life will be addressable, identifiable and traceable using wired or wireless networks. Things that are connected can be controlled and accessed through web like smartphones or other devices. Internet of Things provide access to anything, anytime from anywhere. It refers to uniquely identifiable objects and their virtual representations in an internet like structure. RFID tags are used in most of the places for identification of items and they seem to be prerequisite for Internet of Things, either RFID or you can make use of sensors to have the realization of Internet of Things. Then we are going to talk about the next topic, which is big data. We are having different units of this big data. Already I have given some introduction about big data in the previous episode. Here we are having the minimum unit is 1 bit, then we are having 1 byte. Once if you have 1024 bytes, it is 1 kilobyte 2 power 10, and you are having approximately 1000 kilobytes equivalent to megabytes, 1000 megabytes equivalent to gigabytes, 1000 gigabytes equivalent to tera, 1000 tera 1 peta, 1000 peta 1 exa, 1000 exa 1 zeta, 1000 zeta 1 iota. So, these are the units we are using, and when you consider the data throughout the world, here the text data is occupying this much percentage, the data warehouse created by the enterprise this much, all the remaining things are your data. So, we are having hardly about 25 to 30% of the text as well as enterprise data warehouse. All other data are our own data only. So, you can imagine how much data we are having, because these text data can be easily processed. This enterprise data will also be stored in a particular manner. So, these things can be easily processed, whereas this much data we do not know how to process it. That is what we say big data is. So, 5 V's of big data already we have discussed: volume, veracity, velocity, variety and value. For the banking, marketing and IT sectors, we make use of volume, velocity and value. For healthcare and life sciences, we need veracity. Veracity means conforming to the truth. You should know whether it is accurate or not. In case of healthcare, if somebody says that these are the side effects for this particular medicine, how do you believe it? You want the authentic information, accurate information. So, the truth is very important in case of healthcare and life sciences. So, the definitions, all those things we are having, and there are two types of patterns in big data. When you want to process big data, you are having big patterns as well as little patterns. That big pattern is called as complex event processing, that is CEP, and another one is little patterns, that is online transaction processing. We are using both complex event processing as well as online transaction processing. When you consider the little patterns, online transaction processing, first of all we used the database management system, so that you can use the data stored in the database, retrieve the data and manipulate the data. We used old SQL. In the old SQL, it is very slow. Of course, it followed the ACID properties. Then we use the NoSQL, not only SQL. It gives up both SQL as well as ACID properties for transaction. Now we are having new SQL. It retains both SQL as well as ACID properties, and we are going for the new architecture based on the new SQL. Why so many changes from SQL to NoSQL, NoSQL to NeSQL? Now, when you consider the NoSQL, it refers to the broad class of database management system, which is different from the widely used relational database management system model. Actually, NoSQL databases are not generated primarily on tables and generally do not use conventional SQL for data management. They are often highly optimized for the data. Whenever you are having enormous data dumped into the web, how can you make use of it for the purpose of just storing the data and retrieving the data? It is very difficult. That is why the NoSQL is being used for managing the enormous data. You are having different samples of this NoSQL. The open source NoSQL things are this Cassandra, it is used in Facebook and Twitter, Hypertable, Mongo database, Couch database, Memcached. This Memcached is used in Wikipedia. So, these are all NoSQL available. To summarize this episode, we have discussed about data, information, knowledge and wisdom, and also we have discussed about Internet of Things and big data. To revise the concepts which we have discussed, you can try to answer the following questions. What is the difference between information and knowledge? Next question is, what is wisdom? Then you can just list out some of the applications which are suitable for Internet of Things. What are the various technologies useful for implementing Internet of Things? What are the limitations of IoT? What is big data? What are the patterns used for processing big data? Thank you.